For nearly half a century, stealth has been the crown jewel of air dominance. The F-117 Nighthawk ghosted over Baghdad in 1991, invisible to Iraqi radar. The B-2 Spirit became a flying shadow, able to slip past defenses and strike anywhere on Earth. Stealth was not just an advantage, it was a revolution. But revolutions don't last forever. Technology advances on both sides, and today, a question is quietly taking shape in defense circles. Is stealth dead? Stealth began not with futuristic fighters, but with equations. In the 1960s, a Soviet scientist named Pyotr Ufimtsev published obscure work on the physics of radar reflection. Western engineers realized his math could predict how radar waves would scatter off an aircraft. Lockheed's Skunk Works took that math and built the unthinkable. A jet so angular, it barely looked like an airplane. The F-117 Nighthawk. Its faceted skin deflected radar away. Its black paint swallowed light. It was slow, clumsy, and ugly, yet it was untouchable. In 1991, during Operation Desert Storm, F-117s flew nearly 1,300 sorties and struck at the heart of Saddam Hussein's defenses without a single loss. Stealth was no longer theory, it was dominance. The B-2 Spirit refined the idea. Smoother curves, better radar-absorbent materials, global reach. Later came the F-22 Raptor, mixing stealth with speed and maneuverability. And finally, the F-35 Lightning II, built not just to vanish from radar, but to be a sensor fusion hub in the sky. For decades, these machines defined power. Nations built entire strategies around them. But every sword invites a shield. Radar never stopped evolving. From the moment stealth jets first flew, radar engineers have been working to unmask them. Traditional radars operate on narrow frequency bands, easy to trick with coatings and shaping. A stealth jet reflects those signals away, leaving an empty screen. But radar itself has changed. Enter multistatic radar. Instead of one dish transmitting and receiving, you scatter transmitters and receivers across wide areas. Each beam comes from a different angle. Each frequency interacts differently with the aircraft's skin. Even if a stealth jet slips past one beam, another might catch the disturbance. The sky becomes a web of invisible tripwires. Break one, and your presence is betrayed. Then comes low-frequency radar. Stealth aircraft are optimized against high-frequency tracking radars, X-band, Ku-band, the kind used to guide missiles. But drop to VHF or UHF, the kind used in the earliest days of radar, and the carefully sculpted stealth geometry behaves differently. The aircraft reflects more energy than expected. The picture isn't crisp. You won't see a clean outline of a jet. But you'll know something large is moving through the air. In combat, that's enough. Something is there, and that's all a missile battery needs to aim in the right direction. And that's just the beginning. Quantum radar promises to rewrite the rules entirely. Using entangled photons, it could detect stealth aircraft with precision, immune to traditional jamming. In theory, it works like this. One photon of an entangled pair is sent toward the sky, the other is kept on the ground. When the returning signal is compared with its twin, any stealth tricks, absorbing, scattering, or cloaking, become harder to hide. China has claimed progress, even publicizing prototypes. Western experts remain skeptical, but the race is on. If quantum radar works, invisibility itself may be impossible. Passive detection networks offer another path. Instead of sending out radar pulses, these systems listen. They use the environment as their transmitter. A stealth jet flying through the modern world is surrounded by signals, television towers, cell phone networks, GPS satellites, even cosmic radio noise. As it moves, it disturbs these backgrounds, like a fish cutting ripples in a pond. Arrays of passive receivers, spread across a country, can compare notes and triangulate where the disturbance came from. The jet doesn't reveal itself by what it reflects, but by what it disrupts. Then there are infrared satellites. Stealth hides radar reflections, but heat is harder to mask. A jet engine burns hot, The exhaust plume glows against the cold vacuum of space. New high-resolution IR satellites can scan thousands of miles of atmosphere at once, picking out faint heat signatures against the night side of Earth. In the Gulf War, early IR sensors struggled. Today, advances in cooling, optics, and AI pattern recognition mean a stealth fighter's exhaust may stand out like a flare in the dark, and the sky itself may betray the intruder. Acoustic and atmospheric sensors are emerging tools. Every supersonic aircraft leaves a shock wave. Every high-speed jet pushes air aside, leaving microturbulence in its wake. Even subsonic stealth planes generate disturbances, tiny shifts in air pressure, humidity, or ionization. On the ground, sensitive microphones can listen for patterns no ear could hear. From orbit, satellites may track subtle flickers in cloud layers. A stealth jet might vanish from radar, but it can't fly without moving the air around it. Individually, none of these systems are perfect. A stealth jet may slip past one or confuse another. But modern militaries are no longer betting on a single eye. They are building multi-sensor kill chains, networks where radar, infrared, acoustic, and atmospheric data all fuse into one picture. AI stitches the signals together, drawing certainty out of noise. The invisible jet doesn't need to be painted in sharp detail. It doesn't need to be locked onto by a missile seeker. It only needs to be detected. Once you know it's there, you can aim defenses, launch interceptors, and deny it the freedom it once enjoyed. Stealth was once the ultimate predator, invisible, untouchable, unstoppable. But predators don't stay on top forever. Every ghost leaves a trace, and every advantage breeds a countermeasure. Now, in the counter-stealth revolution, it's no longer clear who stalks who. The hunters may be about to discover they are the hunted. Above it all, satellites are changing the game. During the Cold War, space was already the silent watcher. Early satellites scanned for the telltale flare of missile launches, primitive eyes staring down at Earth to catch the first glow of nuclear fire. Those systems were crude, but effective. They proved the value of looking down from orbit. Today's satellites can do far more. They can track vehicles rolling across deserts, warships cutting wakes across oceans, even individuals moving through cities. Cameras, radar, and infrared detectors already make Earth one of the most observed planets in the solar system. But tomorrow's satellites may take that surveillance to an entirely new level. Imagine constellations not of dozens, but of hundreds, perhaps thousands, of small, cheap satellites working together in swarms. Instead of snapshots, they would provide a constant, unblinking gaze, real-time monitoring of the atmosphere, the oceans, and the skies above every continent. A permanent awareness field where nothing truly goes unnoticed. And these new constellations won't just be looking for light. They'll be tuned to everything stealth aircraft disturb as they fly. Sensitive instruments could listen for subtle shifts in air pressure, the whisper of thermal wakes, or even faint electromagnetic anomalies caused by the interaction of an aircraft's systems with the environment. An F-35 slicing through the upper atmosphere might not shine on radar, but it could leave a fingerprint across multiple sensors, a trail of heat, turbulence, and ionization, invisible to the human eye but obvious to machines. Fuse that data together, infrared imagery, radar reflections, atmospheric disturbances, and electromagnetic noise, and stealth begins to unravel. Where one sensor sees only uncertainty, 100 sensors can form a picture. Where one eye is fooled, 100 eyes working together find the truth. This is the future many scientists theorize, a global sensor fusion web, powered by space. AI and machine learning trained on years of data would filter out the clutter and highlight anomalies in seconds. Stealth jets might still avoid one radar, but not the overlapping layers of surveillance from orbit, from the ground, and from the sea. The implications are staggering. In such a world, stealth doesn't vanish, but it changes. The race would no longer be radar versus shaping. It becomes sensor fusion versus sensor evasion. Can stealth aircraft adapt by generating their own electronic decoys? Can they manipulate atmospheric wakes, or shed heat in ways that fool multiple sensors at once? Or will tomorrow's stealth look entirely different, shifting from hiding the plane itself to hiding it in plain sight, lost in a sea of false targets? For decades, space was the high ground. In the wars of the future, it may become the ultimate battleground, not for missiles or lasers, but for information. The side that masters space-based sensing may hold the power to make the invisible visible once again. So, is stealth obsolete? The answer, like most things in science and more, is complicated. On one hand, stealth is undeniably harder to maintain. Aircraft like the F-117 and B-2 were marvels of their time, but they were designed against the radars of their era. Their skins, their shapes, even their coatings were optimized for the technology of the 1980s and 90s. Today's networks use wider bands, overlapping frequencies, smarter software, and AI-enhanced tracking. Staying invisible is no longer guaranteed. A jet that once flew unseen may now appear as a faint blip on the edge of multiple systems, a ghost that can no longer hide forever. But here's the thing. Stealth has never truly meant unseeable. It has always meant harder to see, harder to target. A stealth aircraft doesn't need to vanish completely. It just needs to stay hidden long enough to strike first, or to survive an encounter. Even if it can be detected at long range, the real trick is to avoid being tracked precisely enough for a missile lock. Stealth buys time. It creates doubt. It injects confusion into the kill chain. And in combat, seconds of hesitation can mean the difference between victory and disaster. And stealth itself is evolving. New materials, new physics, new ideas are reshaping the game. Engineers are experimenting with radar-absorbing metamaterials, engineered surfaces that bend and twist electromagnetic waves in unnatural ways, directing them harmlessly around an aircraft, like water flowing around a stone. Some designs propose active cancellation systems, where the aircraft emits carefully tuned signals to cancel out its own radar return, erasing itself from the screen in real time. Others speculate about plasma cloaking, surrounding an aircraft with an ionized layer of gas that scatters and absorbs incoming radar beams. Fringe theories go even further. Could an aircraft someday use quantum stealth materials that manipulate photons at the quantum level, making a jet not just radar invisible but optically transparent from certain angles? Could advances in adaptive camouflage skins allow planes to literally project the sky around them, like a chameleon blending into the heavens? Some researchers have even toyed with concepts of gravitational distortion, bending space-time itself just enough to alter the path of incoming signals. It sounds like science fiction, but then again, stealth itself once did too. Because stealth has never been static, it has always been a moving target. From angled panels to smooth curves, from simple coatings to nanostructured materials, every generation of stealth has looked different from the last. And the next may look stranger still. Tomorrow's stealth might not mean hiding the aircraft at all. It might mean hiding in the data. Filling the skies with decoys, false signals, and digital ghosts, so that the real aircraft is lost in the noise of 1,000 illusions. So, perhaps the better question isn't, is stealth dead, but what will stealth become? Will it be a cloak of plasma, a skin of metamaterials, or an AI-driven deception field? Will it be physical, electronic, or something else entirely? What we know for certain is this. Invisibility is not an end state. It is a race. And as detection grows sharper, stealth must grow stranger. Stealth began not with titanium or jet engines, but with math. Equations scribbled in a Soviet journal, formulas describing how waves scatter and bend. Equations that Western engineers saw not as abstractions, but as blueprints for a new kind of warfare. From that math emerged the impossible. Jet black triangles, faceted and alien, haunting the night skies over Iraq. Aircraft that looked more like spacecraft than planes. Ghosts that slipped past defenses and rewrote the meaning of air power. But every advantage is temporary. Now, in an age of quantum sensors, global satellite webs, and AI-driven data fusion, stealth faces its greatest challenge yet. What was once a near mythical cloak of invisibility is being pulled at from every direction, pulled by radars that use entire continents as their transmitters, satellites that watch in infrared and ultraviolet, and algorithms that can detect the faintest ripple left behind in the atmosphere. Maybe stealth won't die. Maybe it will transform. It could move beyond shaping and paint, into realms that once belonged only to science fiction. Adaptive camouflage skins that project the very sky around them, plasma fields that scatter radar like mist, or active electronic deception that floods enemy sensors with phantom aircraft, forcing them to chase ghosts across the sky. The stealth jet of tomorrow may not vanish. It may confuse, overwhelm, and misdirect, turning invisibility into a weaponized illusion. And yet, the story of stealth is older than radar and jet engines. It is as old as conflict itself. From painted shields in ancient wars to camouflage nets in World War II, from false decoys on battlefields to radar-absorbing wings, every age has had its own kind of invisibility. Each advance in hiding has forced a new advance in seeing. Each breakthrough in detection has forced a new way to disappear. It is a cycle, a race, a duel that never ends. So stealth is not dead. Stealth is evolving. It is becoming stranger, more exotic, more reliant on the edges of physics and engineering. But a question remains, hanging in the air like the shadow of an unseen plane. How long can it last? If you enjoyed this deep dive into the future of stealth, hit that like button. It really helps the channel grow. And don't forget to subscribe so you don't miss our next exploration into the technology shaping tomorrow's world.